Question 8, all about the coordinate geometry. You've got to find an equation of a line joining A and B, giving your answer in the form ax plus by plus c equals 0. No thanks. Where a, b and c are integers. So we'll worry about this form in a minute. We just want to find the straight line joining these 2 points. So I always write myself y equals mx plus c. That reminds us what I've got to find. We've got to find m, which is the gradient, and then c, which is the y-intercept, but we'll find c after we've got m. M is equal to y2 minus y1 over x2 minus x1, which is, I'll pick these to be my y2s and x2s, and this to be my 1s. Just means I'll get a positive answer. So y2 is 4 minus 0, and x2 minus x1 is 7 minus 2, which equals 4 over 5. So that's the gradient. So we can then write y equals 4/5 x plus c. And to find c, as long as you know a point that lies on the line, we know 2, you can substitute that in to find c. I'm going to use this one for the only reason that there's a 0 there. It might make the number work easier. So if x is 2 and y is 0, substituting that in there, we get 0 equals 4/5 multiplied by 2 plus c. So 0 equals 8/5. Remember, it's just the 2 times the 4, not the 5. Plus c. So c equals -8/5. And then we just need to pop that back in here. So we end up getting final answer. Therefore, equation of line AB is y equals 4/5 x. Take away 8/5 because that was c. Remember, it says you have to leave your answer in the form ax plus by plus c equals 0. And a, b, and c are integers. So we need to multiply everything by 5 to get rid of the fractions. And then rearrange so it's ax plus by plus c. I'll leave the x's where they are because they're positive. Take the y's over. Still be -8, and it equals 0. So that is your equation of your line AB. The next part, turn this down a bit. Part B, we have to find the length of AB given your answer in third form. Well, the length, you could just do Pythagoras and draw it out, or there is a formula. I'm going to get rid of all this. We don't need this. So make sure you've got that down, because it's going. Gone. So part B, if you know how to find the distance between 2 points, i.e. you know this formula, x2 minus x1, that's the distance between the x's squared, plus y2 minus y1 squared, that will give you the distance between these 2 coordinates. It's just Pythagoras. If you're not sure on that and you prefer to draw things out, it takes a little bit longer maybe, but if you just plot these points roughly, 2, 0, that's here, that's part B, and 7, 4, let's stay here, that's here, and we want to find this distance. Let's have a nice straight line. Oop. There. You can just use Pythagoras because for any line you can make a right angle triangle by going along and down. You could have gone this way, and then work out the distance and use Pythagoras. So the distance for this one here, these are the y coordinates. Well, the y coordinate here is 0, and the y coordinate here is 4. So this distance must be 4. And here, the x coordinate, well, this is 2 along, and this is 7 along, and the difference between 2 and 7 is 5. That's exactly what you're doing here, just in a more formal way. Pythagoras says we have to square them and add them, and then find the square root of that. It's exactly what's done here. This is just, again, like I said, this is the formula. This is just a more messier but more understanding way for some. Root 41, it says give your answer in surd form, and that is, so that is the distance from A to B. The point C has coordinates 2t, where t is greater than 0 and AC equals AB. Find the value of t. Now there's a few different ways of doing this. Some are much longer than the others. Because it's only one mark, it must be pretty straightforward. So look closely at your diagram. It says the point C has coordinates 2t. Well, because this is 2, 0, the point C must be on this line somewhere. Somewhere on here. Because this is 2, 0 and that is 2t. It says that AC equals AB. So the distance from A to C is the distance from A to B. So it makes it like an isosceles triangle. A to B is the same as A to C, so about here. So that is 2t. So this distance from A to C is the same as A to B. And we've got a nice isosceles triangle there. We have to find the value of t. Now if we look at this, because it's an isosceles triangle, this one here, this triangle here, oops, is exactly the same as this triangle here, congruent triangles. So because this distance here is 4, this distance up here must also be 4. And therefore we can work out how high up this point C is, and then we'll know the y coordinate of t. So if this is 4 up and this is 4 up, because this point originally was 0, then this point must be 8 above the x-axis. So this here must be 8. So t equals 8. Again, just because using the fact that these two triangles now that were formed are congruent, they're identical, the height from the x-axis was 0, because this point here is 2, 0. So this is 4 above, so this is 8 above. So that must be 8 on the y-axis. Then, that's one easy mark there. For part D, we have to find the area of the triangle ABC. So that is A to B to C. So this triangle here, we've got to find the area of. Now, we know this distance here, that's 8, and the perpendicular height is this distance here, and we know that earlier, found it, that's 5. So for part D, we'll just squeeze it here, we'll stick with the blue. The area of triangle ABC is a half base times height, so that's a half times 8 times the height, this perpendicular distance here, which is 5. So it's a half times 8 times 5, which is going to be 20. You can put units squared if you want, but 20 is fine. You don't put centimetres squared, it's not measured in centimetres. So the area of the triangle ABC is 20 units squared, or just 20.